Hey guys. Okay, so I'm recording this all on the same day. I don't want you to think I'm wearing the same stuff for like multiple days, right? Okay. So I'm out again with Mr. Schultz, and I wanted to make sure that you got your math lesson in. This is lesson 29.3, where we're going to be discussing classifying two-dimensional figures, but instead of doing it with the Venn diagram, we're going to use the tree diagram, which I know you guys actually like better, but these are going to be a little bit more detailed than what we had been doing. Some of these are going to be branching off in all different directions, and we're just going to do it the best that we can, okay? So, but first, let's get our minds going. Let's look at these shapes. Whoa, wow, here we go. I've got a square, and, well, I have a rectangle, and I have a rhombus. So it's asking me to name two attributes, fancy word for characteristics, that these shapes share. What do I know? What do I know? I know that they all have four sides. Okay, so they all have four sides. So that's an attribute that they share. Well, if they have four sides, that means that they have four interior angles. Four interior angles. Okay, so that's what they have in common. Now I got to think to myself, what is it that they do not have in common? Give me a second to look. One thing that comes to mind is angles. We've been talking a lot about interior angles. This guy's got four right angles. The rhombus does not. So that's an attribute that they do not share. What else? Equal sides here. Rectangles we know do not have equal sides, all four sides. So that could be something they don't have in common. All right, so let's get started. We're going to do a major tree diagram. I can't wait. Okay, so we're going to make a tree diagram to show the hierarchy of the following shapes based on their properties. Oh, wow. Look at all these shapes, you guys. A rhombus, a trapezoid, a polygon, a square, a quadrilateral, a rectangle, and a parallelogram. Use the exclusive definition of trapezoid in your diagram. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. Then we're going to classify these shapes into as many categories as possible. It's going to take a lot of thinking. So let's start at the top. What is the most general category? Did you say polygon? Because that's what I'm thinking. So if I start with a polygon, what would be next? Polygon. What can I break down my polygon into? What would be like another category? So looking, okay. I already know. Julia's probably thinking in his head, I don't know, Miss Schultz, I might have tried something different. Who knows? Okay, so I'm going to go quad. So now what I'm asking myself, okay, quadrilateral is a polygon. Now I've broken it down into a quadrilateral. Now I have to say, what two things listed here are examples of a quadrilateral that can fall underneath the quadrilateral but don't have neither kind of space. So I'm going to go trapezoid for sure. So this is where our tree diagram gets a little different. So I'm going to kind of come off here. And I'm going to write trapezoid. And I just got it. Okay, trapezoid. And another category that I could branch off of quadrilateral is a parallelogram. Okay, so now I have a parallelogram. So I'm crossing these off. Remember I told you I crossed them off so I know what I have left. So now what do I have left? I have rectangle, square, and rhombus. I'm starting to think back to Friday's lesson, probably because I just recorded it. And I'm thinking, Oh my God, that Venn diagram. And it was like rhombus, rectangle, and in the middle was square. Huh. So I'm thinking I'm going to branch my parallelogram off into a rhombus, into a, oh my gosh, a horrible shaped rectangle. Oh, I can't draw this in my life. Okay. And then a square has qualities of both. So watch this. I can make a V like for Victoria. And I can write in here square. Wow. That's some crazy. But what I want to do here is I want to just review what this is even mean. Everything underneath polygon has the qualities of a polygon. Okay? Which is a plane figure, flat figure. That's what a polygon is, a flat figure. With at least 3 straight lines. At least 3. And it has angles. Okay. So if I go back up here, an example of a polygon that's still broad enough would be a quadrilateral. Because both trapezoid and parallelogram, those are kind of broad. Those are broad attributed descriptions. So they both fit under quad. So I split my quadrilateral into a trapezoid and a parallelogram. Then I went back up and I still had 3 shapes left. Well, nothing falls under trapezoid. So there's no, that side of my tree diagram is it's done. I don't have anybody that fits any of those categories. It fits under that category. But a rhombus and a rectangle and a square are all examples of a parallelogram. So they're all going to branch off of there. The reason I connected square to rhombus and rectangle is because squares have the same attributes of a rhombus and a rectangle. So it's important for me to do that. Okay? Just give me a second to kind of ponder. I know it's a Monday. You get off weekend. I don't know. So you might be in it. And the expectation is you're drawing this in your workbook. Right? All right. So we are going to look at this. What would it look like if it was a Venn diagram? Okay. Again, it's the same philosophy. Large category of polygons. Everybody is at the polygon. Okay. Then we have everybody's quadrilaterals. Well, trapezoid has to be on its own. It doesn't have any buddies. But parallelogram, well, parallelogram, they're like groups, right? Rhombuses, squares, and rectangles. All fit in there. All fit in there. Now, we could, instead of, we did a vertical one, but we could go horizontal if we wanted to. It's the same philosophy. It's whatever, what do you feel comfortable with? What do you like? Do you like it to be vertical or do you like to be horizontal? It's giving the same amount of information. So if I started with polygons as my huge category, and then bringing it down, bringing it down, bringing it down. So I've got my quadrilateral. This is where we put parallelogram. Hello, you need to be writing this in your workbook. I know some of you aren't, right? And then parallelograms, we said were rectangles and rhombuses. And square just loves qualities of everybody. So square is at the end. This is still considered a tree diagram. It's just showing it to you horizontally versus vertical. There's no right or wrong. It's whatever your preference is. Some of you may like the Venn diagram better than that, and that's fine too. Okay. So, if we were to go back to that Venn diagram, which part of the diagram shows the most general? The most general. I think it's a giant hula hoop, a huge hula hoop. That's the general one. So that's the outermost ring. Let's call it the outermost ring. And that outermost ring showed us polygons. It was a polygon, that outermost. And then it says, well, then which part of the diagram is the most specific quality? The most specific one was what? know. What are you thinking? There's actually two. Let's go back. Okay, polygon, general. What's the most specific here? What's the most specific here? Who's all by themselves? No buddies. Trapezoid. No buddies. Square. Nobody's coming out shooting out after them, right? So trapezoid and square, those are the ones that are most specific because there's no subcategory. Most specific is the trapezoid and square. And it's important that we write the because. Write it. Because they have no subcategory. Sorry, I know it might be hard for you to read this, okay? So let me say this again. The huge circle of the Venn diagram, the big outer part, is an example of a polygon. Most general, right? Sort of like saying Cranford schools. Cranford schools. That's just a general statement. The most specific was trapezoid and square because nobody shot out after them. There was no subcategory. Brookside Place. There's no other school within this school, right? Okay. So now for number 2, it says, how is the tree diagram similar to the Venn diagram, and how is it different? Well, they're both showing us, the whole point of doing this is to show the hierarchy of categories. So they're similar, both show us categories of the shapes, okay? But here's where they're different. Here's how they're different. The Venn is going to use regions or circles, okay? And then the tree diagram, that branches off. That's why it's called a tree diagram. It branches off to show us those different qualities or attributes that we might see. Time to think that through, write it down. The next one says, how can you see all of the categories that a shape belongs to if you're using a tree diagram? Okay, and then what are all of the categories that shape A would belong to? Okay. Basically, what you're going to do is you're going to follow that tree diagram, whether it's down if you did it vertically or across. You're going to follow it down. And basically, if we look at shape A, which is a rhombus, it's also going to fall into the category of a parallelogram, polygon, quadrilateral, and rectangle, right? So just follow the tree diagram. Now again, it could be left to right or top to bottom, however you make them. If you make yours vertical or you make yours horizontal, that's really how you're going to be able to decipher which way to follow it, okay? Why do the branches that come off of rectangle and rhombus lead to square? Because square has the qualities or the attributes of both a rhombus and a rectangle. So, however you want to write it, squares have the same attributes. We want to start using attributes of rectangles and rhombuses. So that's why. Now, if you're point you're like, my head is gonna burst. It's a Monday morning. You're gonna get on that Google Hangout and you're gonna type me a message and we're gonna work that through. Okay? So you can get onto the Google Hangout, type up a question. You know, I check it throughout the day and I will get back to you if you're kind of like, right? Okay, I want to skip around here. Let's go to this one. Cyrus made the following tree diagram to show the relationship among scalene triangles, equilateral triangles, and isosceles triangles. Is his diagram correct? Well, we start at the top. Is scalene, equilateral, and isosceles all types of triangles? You have a chart paper right in the front of the room if you're not sure. Yes, they are. They're all types of triangles. So, scalene is a type of triangle, and there's no qualities or subcategories. Okay, so let's take a look at this. An equilateral and an isosceles are examples of triangles. That is definitely true, Cyrus. That is definitely true. Does an isosceles triangle have the same qualities of an equilateral and then some? Well, let's go back to the definition that's in front of the room. An equilateral has three sides that are the same length and three angles are the same. An isosceles has two equal sides and two angles that are the same. Uh-oh. That doesn't seem right. I think Cyrus made a mistake. What do you think? Write a response. Why is this wrong? What did he do wrong here? Here's what he did wrong. Okay. All isosceles triangles do not follow the attributes of an equilateral. However, if Cyrus switched them and put isosceles here and equilateral there, then guess what? He would have been right. So to correct this issue, we would have triangles up here, okay? Then here I would put isosceles. Then after that, I would put equal lateral. And of course, scalene is all by itself. The reason this one works is because does an equilateral have at least two sides that are the same length? Yeah. Does an equilateral have at least two angles that are the same? Yeah. So Cyrus just made a mistake. He needed to what's called flip-flop it. He needed to flip-flop that to make it work. So he made an error. Let's try another one. An equilateral triangle has three sides that have all the same length. That's why it's called equal. You let the words help you figure these things out, right? Equilateral. An equilateral triangle may also be called an equiangular triangle because each of the three angles has the same exact measure. Okay. So I'm going to butcher this. You know I can't draw. Holy Moses and Mary. Okay. The angle here, here, and here, they're all going to be 60 degrees. Because when we're doing angles in a triangle, all three equal 180 degrees. Always. So, they want us to come up with another category to show where an equiangular triangle would go. Okay. So let's review, and you may not have gone through last year, pandemic, don't worry, no judgment here. If we're going to an obtuse angle, we're talking 91 degrees to 180, right? A right is only at 90 degrees, and a cutie, oh, did that count? Right? We're going to go from 1 to 89 degrees because they're so cute. So where would I put an equilateral? If an equilateral triangle has all their angles at 60 degrees, where would I branch them off? Draw what you think. Did you do it? Are you ready? Okay, I would put it here. I would add an equal, oh, they want us to call angular, right? Equal angular here because it's at 60 degrees. So it would fall within what's called the range of 1 to 89 degrees. So an equal angular would go here because it's only made up of little cutesy angles. So cute. Okay. So tonight, what you're going to do for me is you're going to make a tree diagram, of polygons. Okay. And I'm going to tell you right now that one shape is going to be ousted. It's going to be all by itself in the tree diagram. So we're going to have polygons, and it's going to go in two branches, and one's going to be all by itself. Sorry, you don't fit any other category. And then one side's going to be really long. So for homework tonight, you're going to do pages 601, 602. When you get to number 5, there's going to be 1 always, 2 sometimes, and 1 never. And you know, if you get sometimes late and you're starting to panic, don't worry. If I can jump on a Google Meet, I will do my best. I don't know what Monday's going to bring because right now I'm coming to you live on a Thursday. So we'll do the best we can. All right. I will be back tomorrow to be with you and teach you in person, and it's going to be great. But you can Google Hangout me with any problems or misconceptions. But I think it's pretty straightforward. If you need me, I will be there for you. Okay. Miss you guys. See you tomorrow.